Hello, in this video I am going to walk you through the flow of HTTP and SSL and HTTPS traffic through explicit ProxySG. So let's dive into it. So the first flow we're going to cover is the SSL interception. So this is our proxy device, ProxySG, whether that's physical or virtual SGVA or an ISG application on SSP, doesn't matter. All the same, it is an explicit proxy. Since we're talking about SSL, the client is going to send a connect that will be formatted on the wire and encoded and sent on the TCP socket looking like this. You get the connect followed by the host, by the port, by the HTTP protocol. Here in my example I'm using 1.0. Then you get the line breaker, you then get the host, another line breaker, user agent that has got some string, another line breaker and proxy connection, keep alive, line breaker, and end of the headers with another line breaker. Now the order of host, user agent and proxy connection doesn't matter. You could have user agent first and then host. It really depends on the client, on the browser, so on and so on. Also, the minimum 3 or 2 are really the first line and the second line. That is the absolute minimum that you have to send to the proxy. You don't have to include the user agent. There's a ton of clients, applications out there that don't do that. Browsers always do. They always include the user agent string on the connect, and the proxy connection, the proxy connection header. It's again, optional. It doesn't have to be there. Sometimes, based on the client, you could get more than this, right? Now, so let's have a look what happens then. This hits the proxy. It hits the proxy first on a TCP level, because we are in TCP IP network. And at this point, what the proxy has, it can evaluate only data on a TCP level. So we're talking about IPs and ports. And at this point, the proxy is going to get something like this. There's an example, right? So this is the source IP, some random high port that I put there from the client. This is the proxy IP, because we are explicit here. The destination IP, of course, that the client got either from the proxy setting or the pack file, is going to be the actual IP on the proxy, or if there is a load balancer, it could be the VIP first, but this demo doesn't cover load balancers, so this client goes directly to the proxy, and the proxy port 8080. Now, at this point, the proxy has got a simple, decision to do, which is go through the proxy services, go through the listeners, and find out, do I explicitly listen on this IP, or maybe all of my IPs on that interface where that frame, that packet has arrived, that TCP SYN has arrived, and is the port right? And if the answer is yes, then the proxy will TCP intercept that. If not, it will be bypassed. Of course, in explicit proxy, that means end, and the TCP socket is going to be reset by the proxy. Here we do TCP interception. It then moves to the HTTP proxy. Why does it go to HTTP proxy, you may ask? Because this is SSL. Well, it's because it's explicit proxy, so we first have to handle the connect. And what we can do here, we can only do stuff with what's here, what is sent to us in a connect. And there is very little information there. So at this point, the proxy can make the decision based on the fields that are in the connect. Now, the good news is that we have got the host there, we have got the port. So at this point, the proxy could have a policy that say that if the connect host is, I don't know, malicious.com, block it. If the connect host is Google, allow it. If the connect host category is, I don't know, search engine portals, allow it. If the connect host category is, I don't know, social networking, block it, right? So it can only make decision based on what is this. It's not a limitation of the ProxySG, it is limitation of how TCP IP works, how connect tunnel works. The proxy only gets this information, so it can only make decision based on that information. And here I have listed what I just said, few examples, so we can do something with the connect host and the category, so on, so we can do something based on a port. Of course, this is the point on explicit proxy where authentication happens. This is where the proxy could challenge back with the 407 and say, please authenticate to me. I support Kerberos NTLM basic, or maybe just basic, maybe just NTLM, maybe just Kerberos and NTLM. This is also the point where the proxy decides what to do with protocol detection. Do I try to detect what is inside after this connect tunnel? Is it SSL or is it something else? And then hand off to the correct proxy service. When I say proxy here, I'm not talking about different proxy device. I mean different proxy services within the proxy device. Of course, you could do a DLP, so there's a DLP checkpoint here, right? You could decide to send your connect to DLP because somebody could try to leak something in the connect header here. You could actually inject a connect payload here, right? Where you could hide some PII information or something. So you could decide to send that for a DLP scan to an ICAP server via the RecMod ICAP. And of course, we can do policy decision based on the connect user agent string. Now, a lot of customers I work with kind of use that to then make the decision based on do I SSL intercept or not. But we will get there in a minute. So let's say that at this point, this is example.com, which belongs to category technology internet. Our policy allows us. So the connect gets allowed. What happens after that? Of course, the client after that sends the client hello, and the start of SSL handshake starts. Right, so we are now on SSL proxy. If you look at this on a trace, this would be the TCP transaction. And now we did the protocol detection, we handed off to SSL proxy. You then get the SSL, the unknown SSL transaction logged in the policy trace. And what do we do here? Well, the standard SSL checks, right? After all, the proxy is SSL server to this client, but it is also SSL client to the server side connection. So the proxy would fetch the certificates and validate them and so on, so on. This is also the point where we have to decide whether to SSL intercept or not. And we can do some manipulation based on, do we want to downgrade TLS, upgrade TLS, don't use this cipher, use this cipher, and so on, so on. Let's say that we do take the decision to SSL intercept because this is SSL interception flow. So we SSL intercept. What happens next? Well, after the handshake is done, and now we're talking about handshake between the client and the proxy. So the proxy is going to see what comes next, and what comes next is the actual HTTP data now, the HTTP headers and the HTTP payload. So in this demo, I put here that this is a post, and we are posting file.exe to that host. It's got a content length of 6 bytes, which is this 1, 2, 3, 4, 5, 6. And it's got the content type of text HTML. We have got the current and the correct format in here. The end of headers here. Start of payload, end of payload. 0 bytes left. End on a socket. Right. At this point, the client has done its bit. The proxy would correctly pass this and know that okay, I got what I needed. This is the end of the file. Right. So at this point, we are back to HTTP proxy because this is HTTP. And of course, the difference here is that we now don't make policy decision based on just the host headers, which is this part. We can also now make policy decision based on the payload, and more importantly, this is the first time when we're actually talking about URL, because this is the first time where we see what the URI path is, or what the URI query is, what the file is, and so on, so on. We also at this point do the REST-mod ICAP scan if we want to. We can go to CAS for AV scan. This is where we can do file type control policy, sandboxing, and so on, so on. We can do web isolation at this point, right? All the HTTP level stuff happens at this point. URL filtering and URL categorization, all that. And let's say that we get the decision of allow because yes, this was a post, but we didn't leak anything back. So, DLP didn't block it. CAS didn't find anything back, with the response. Everything is allowed. User gets the response back for this post, and that's it. We are done with this flow. Now, let's look into SSL interception bypass and what that looks like. So again, we got our proxy. We get the same connect as before. There's nothing different. Again, it's the TCP proxy. Everything is same here. We TCP intercepted, and it goes to HTTP proxy because it's a connect. Everything is same here. We allow the connect, goes to SSL proxy, and this is where we now hit the difference. At this point, you can still do something with the certificate, like the validations and stuff. You can, and at this point, we take the decision on the proxy in a policy not to SSL intercept, because let's say that this domain example.com is on SSL interception bypass, or the host category from the connect, right? So I said that this belongs to technology internet, right? Let's say that technology, internet is on SSL interception bypass. So what happens then is that we don't see that HTTP payload, we don't see URL, we don't see the file, we don't see the HTTP headers. Everything is just a cipher stream rather than text. I made a typo there. It's all encrypted data that comes now from the client. We don't see here the post. The proxy has got no idea whether this was post or get or head or patch. No idea what headers there are. It is all encrypted. So I like to say that at this point, the proxy is kind of like a router. It just gets a packet and forward packet. We took the decision to allow this connect tunnel at this point, and then the SSL handshake took place between the client and the server. At that point, once that handshake is done, whatever the client sends and the server responds with, proxy cannot manipulate that in any way because the proxy doesn't see it. The proxy only deals with it at this point on a TCP level, which means it get a packet with TCP segment, send it to the server. Server comes back with some TCP segment. Proxy sends it back to the client. So there's no caching, no header stripping, no DLP scan, no AV scan. Everything gets through. Okay, let's now look at the HTTP flow, which is the last one. So in this case, there's no connect, of course, because it's HTTP. We are HTTP proxy. We don't need to tunnel it first through the connect. We get something like this. This time I just put a get there. Again, the number of headers here differs based on application, right? But the minimum is the first and the second line. And there's nothing different here. We hit it on a TCP level first. We do intercept it. We pass it to HTTP proxy. This time, notice that we can do both header and payload inspection manipulation at this time because we already see it all. And now we just so yeah, these are all the things that we can do, right? Of course, the authentication takes place at this time, as well as all the URL policy decisions take place, right? Both the rec mod and res mod take place at this point. And let's say that we haven't matched, anything, any block policy. We have matched an explicit allow policy rather, based on the host name or the category, and that's it. There's no SSL here. The proxy goes to the server, and server comes back, and that is then forwarded. Well, it goes again through this policy because maybe we do the ICAP scan there and the file that came back from the server is found malicious. But if not, then the proxy will of course send that file to the client. If not, then it wouldn't get allow here. It will get blocked on the way back in. And that concludes the demo. Thank you very much.